Today in physics, we were assigned a project that required us to show these in some way.
While other people are experimenting with toy cars and making lab reports, we will play video games.
The first game up is Universe Sandbox. This game can show uniform circular motion, or better known as UCM. First, we will find the period with this equation, v equals 2 pi r over t, which v represents the velocity of the planet, r representing the radius of the orbit around the sun, and t representing the period. In the simulation, we can note that Jupiter is going at a nice 27,684 meters per second, and is 1.16 astronomical units away from the sun, or approximately 1.735 times 10 to the 11th power meters away. Now we can plug the known values into this formula, which comes out to this, and we can arrange it to become this to find the period of Jupiter in this simulation. The units for period are seconds. The period will be 3.938 times 10 to the 7th seconds, and can also be confirmed in-game here.
Now that we have the period, we can find the frequency, and since the frequency is just the inverse of period, the formula is simply f equals 1 over t. With this, we can find that the frequency is this, which evaluates to 2.539 times 10 to the negative 8 hertz. Up next, we can demonstrate orbital motion with Universe Sandbox. Let's find the velocity of Jupiter's orbit in this simulation. First up, we have to use v equals 2 pi r over t, where r represents the radius of the orbit around the sun, and t represents the period. To find the velocity, let's plug in the known values. This will give us the velocity of Jupiter in the simulation to be 27,682.393 meters per second, which is remarkably close to the simulation's actual velocity, which is 27,654 meters per second.
The final unit we will show in Universe Sandbox is a simple harmonic motion. On screen, you will be able to see Jupiter's orbit around the sun, but from a horizontal perspective. This is a perfect example of simple harmonic motion and shows Jupiter's displacement from the equilibrium, the to and the fro. The maximum amplitude is just the radius of its orbit, which is 1.735 times 10 to the 11th meter. The second and final game will be Minecraft. First, we will find the momentum of the minecarts, then we will show linear momentum with two minecarts colliding with each other. This collision is a general inelastic collision where the two objects with different masses will collide and stick together but go in the same direction at different velocities. Then, we will show elastic collision, which is when two objects collide and bounce off each other.
To find the momentum of the minecarts, we have to use the equation P equals mv, where P represents the momentum, m represents the mass, and v is the velocity. To find the mass of the minecarts, we know that one block in Minecraft is 1 meter cubed. Using this information, we can determine the weight of an iron block, which is 7,873 kilograms per cubic meter. Then we take that number, divide it by 9 to find the mass of one iron ingot, and multiply that by 5 to determine the mass of one minecart, because one minecart is made with 5 iron ingots, which comes out to 4,374 kilograms. Now we must find the mass of the TNT minecart, and all we have to do is add the mass of a block of TNT, which is 1,650 kilograms, to the original minecart weight.
Then we found that both the minecarts move at a velocity of 8 meters per second. With this, we can determine the momentum of the empty minecart is this, which equals 34,992 kilograms per meters per second. And the momentum of the TNT minecart is this, which equals 48,192 kilograms per meters per second. Now we can show you a general inelastic collision between the two minecarts. The TNT minecart will be moving at a speed of 8 meters per second and colliding with the stationary empty minecart. The outcome is as expected with them moving in the same direction, but the TNT minecart is moving at a slower velocity than the empty minecart. Then we will demonstrate elastic collision with two empty minecarts colliding together. The result is both the minecarts bounce off each other but go at a slower speed than initially because kinetic energy is not conserved.
Then we will demonstrate the work and force of minecarts. First, we have to find the force of gravity on the minecart, which is F equals ma, which when plugged in comes out to this, which equals 42,908.94 newtons. Then we will find the work, which is the amount of force being exerted over a displacement. The formula for work is work equals force times displacement, which when plugged in comes out to this, which equals 343,271.52 joules.
Finally, we will show energy by demonstrating gravitational potential energy, or GPE, on sand in Minecraft. Since we know that the acceleration due to gravity is 9.81 meters per second squared, and the mass of sand is 1,631 kilograms per cubic meter, the equation for GPE is mass times gravity times height, which when we plug in is this, which evaluates to 160,001.1 joules. Thank you for your time!
Please give us a 100.